What's up, Simpsonites? It's another beautiful Sim Science Saturday, and we're going to take a little trip down memory lane. Okay? It's going to be very full of nostalgia, but I think it'll be lovely. Okay? So, let's look at what we've accomplished over the past couple of weeks. It's been a nice section, a beautiful section, a knowledge filled section, and truly a lovely time. So, here we start out hot on page 96. 96. My birth year. Beautiful. Just in case any of you were wondering. That's where we slap down our scale that would guide our studies, our wonderful studies, for the next couple of weeks. Over here on 97, we went into the mole and Avogadro's number. We learned about how big a mole is, what Avogadro's number is, and we were filled with joy. Now here on 98 and 99, we started calculating molar masses, formula weights if you will, molar masses, molecular masses, however you'd like to say it. But then we stuck with the term molar mass. And we calculated them, and we did some examples, and it was lovely. Then we went on to page 100 and 101, where we recorded things from when we had a great time with Mr. Menchokster, and we heated up crucibles, and we saw things burn. It was lovely. That's where the lab should be. Then we went on to 102, where we had a fuego foldable, as I like to call them, and we learned about empirical formulas and molecular formulas and the differences between them. Then over here on 103, we did some examples of empirical and molecular formulas, and it was wonderful. Then we went on to page 104, where we began diving into conversion factors, another joyous area of study. And we put in this handout on page 104, and we wrote down these notes on page 105. And we learned about conversion factors and how they're really equivalencies that allow us to go between different units, and it was wonderful. Then we came on to 106 and we did a lot of examples of one-step conversions. Truly a lovely time, truly a knowledge-filled time, and we learned a lot about how we can go in between different things using conversion factors. On page 107, we put in our stoichiometry mole island diagram, which is another lovely piece of study that allows us to go between different things. We used a lot of grams to grams, boop, 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 and it was wonderful. Okay, then we advanced to page 108 with our cat packet, where we did two-step conversions. All right, we stapled together the 3 pages and we glued the back of the last page onto page 108, and there it sits. Now I posted the answers, the work done out for 2 of these other problems in this packet on Angel, if you'd like to see them. And then we did a pop rocket lab. Lovely time, quite fun. A lot of Snapchats were had. A lot of fun was had. Jose Reyes shot pop rockets at me. Not on purpose. I weaved them. It was okay. Shout out Jose Reyes. Then here on page 110 and 111, we have the end of our section. Now, I believe we only answered 3 or 4 of these questions, Cornell notes. I'll give extra credit for answering this one here and doing a summary. Those will both be extra credit if you do them. Now over here on page 110, we calculated, we did the calculations for these here. I know it's a little blurry, but we did these, and it was wonderful. Now, I didn't post a video of this stuff. That's why I have it right here. Let's talk about it. Limiting factors and percent yield. We talked about a limiting factor. It's something that is used up first. And if you use it up first, it's going to limit how much of the product you can make. Because if you're making cheese and crackers, and you have 300 crackers, but you only have 5 pieces of cheese, you can only make 5 cheese and cracker sandwiches. That's just the way it is. Okay? So, up here on this page, what I highlighted a second ago, we figured out which one of these things, either acetic acid or sodium bicarbonate, was our limiting factor. So, refer back to your calculations and see which one allowed for less of the product to be made, because that's going to be where it stops. Okay? Now, the formula for percent yield is where you take your actual yield that you get in a lab situation, you divide it by your theoretical yield, the total possible you could have had, and then you multiply it by 100% to get your percent yield, which tells you how close you were to what you were trying to get. How close to perfection were you? Okay, in this example, it's saying we actually produced 0.45 grams of CO2. That is our actual yield right here. That's what we actually got. The theoretical yield is going to be yield in grams that you calculated up here for the limiting factor. So whichever one of these was the limiting factor in moles, we got that in moles. You're going to take that and you're going to figure out what the theoretical yield would have been in grams. So how many total possible grams could we have gotten? Then you're going to go up here, use this formula. You're going to divide the actual yield by the theoretical yield that you figured out, multiply 100, and you're going to get your percent yield. Okay, and on that page, I expect this all written in the formula, the example, and the definition of the theoretical yield and actual yield. And then I expect to see the math converting moles to grams here, the grams from our question up here, and then the math done out to get the actual percent yield. All right, and it will be wonderful. That's lovely. I hope you've enjoyed this segment of Sim Science. I hope that your notebook looks good, and I hope you're excited to ace this test on Monday.